Hi friends, welcome. This is the part 5 of our mechanical engineering competitive exams theoretical questions and answers series on engineering mechanics. So friends, let's begin. Friends, this is question 201. When the lift is moving upwards with some acceleration, the pressure exerted by a man is dash proportional to its acceleration. Here friends, options are directly or inversely. So here correct answer is A, that is directly. The tension in the cable supporting a lift is more when the lift is moving dash with an acceleration. Options are upwards or downwards. Here correct answer is option A, that is upwards. Next is, if tension in the cable supporting a lift moving downwards is half the tension when it is moving upwards, the acceleration of the lift is, here options are g upon 2, B is g upon 3, C is g upon 4, D is none of these. Here correct answer is option D, that is none of these. Next is question 204. Two bodies of masses m1 and m2 are hung from the ends of a rope passing over a frictionless pulley as shown in figure. This is the figure. The acceleration of the string will be. Here friends, these are the options, and here correct answer is option A, that is g into bracket m1 minus m2 upon m1 plus m2. Next is question 205. In the above question, that is this question for friends, 204 question. In the above question, as shown in figure, this figure, the tension T in the string will be. Here friends, these are the options, and here correct answer for this question is option B, that is 2m1 into m2 into g upon m1 plus m2. Next is for this figure, this same figure, figure 1.49, question number 206. If the masses of both the bodies as shown in figure are doubled, then the acceleration in the string will be. Here options are same, half or double. So here correct answer is option A, that is same. Next is, if the masses of both the bodies as shown in figure are reduced to 50%, then the tension in the string will be. Here friends, this is the figure again, and options are same, half or double. So here correct answer is option B, that is half. Next is question 208. Here two blocks A and B of masses 150 kg and 50 kg respectively are connected by means of string as shown in figure. This is the figure. The tension in all the three strings dash be same. Options are will or will not. So here friends, correct answer is option A, that is will be same. Next is, if two blocks of equal masses are attached to the two ends of a light string and one of the block is placed over a smooth horizontal plane while the other is hung freely after passing over a smooth pulley, then the two blocks will have same motion. Agree or disagree? Here option A is the correct answer, that is agree. Next is for this figure, next question is for this figure, question 1210. A block of mass 20 kg lying on a rough horizontal plane is connected by a light string passing over a smooth pulley to another mass 5 kg which can move freely in the vertical direction as shown in figure. This figure, the tension in the string will dash with the increase in coefficient of friction. Options are increase, decrease, and option C is not be affected. Here friends, correct answer is option A, increase. Will increase with the increase in coefficient. The tension in the string will increase with the increase in coefficient of friction. Next is question 211. A block of mass m1 placed on an inclined smooth plane is connected by a light string passing over a smooth pulley to mass m2 which moves vertically downwards as shown in figure. This is the figure. The tension in the string is. Here friends, these are the options, and correct answer for this question is option D, that is m1 into m2 into g into bracket 1 plus sine alpha upon m1 plus m2. Next is question 212. In figure 1.52, that is, friends, this figure again, if the angle of inclination of the plane is increased, then acceleration of the system will increase or decrease or remain the same. Here friends, correct answer is option B, that is decrease. Next is for the same figure, question again for this figure, question 213. In figure, if the mass m1 is placed on an inclined of plane having coefficient of friction mu, then the tension in the string will be. Here friends, these are the options and question is based on this figure. So here friends, correct answer for this question is option A, that is m1 into m2 into g into bracket 1 plus sine alpha plus mu cos alpha upon m1 plus m2. Next is, which of the following statement is correct in connection with projectiles? So here options are, option A is a path traced by a projectile in the space is known as trajectory. Next option is the velocity of with which a projectile is projected is known as the velocity of projection. Next option is the angle with the horizontal at which the projectile is projected is known as angle of projection. Option D is all of the above. So here friends, correct answer for this question is option D, that is all of the above. All statements are correct here. Next is question 215. The total time taken by a projectile to reach maximum height and to return back to the ground is known as time of flight. Options are yes or no. So here friends, correct answer is option A, that is yes. Next is the Cartesian equation of trajectory is, here friends, these are the options and here mu is equal to velocity of projection, u is equal to velocity of projection, alpha is equal to angle of projection, and x y coordinates of any point on the trajectory after t seconds. So here friends, these are the options and here correct answer is option C, that is y is equal to x tan alpha minus gx square upon 2u square cos square alpha. Okay, now here friends, okay, now next is question 217. The path of the projectile is a parabola. Options are true or false. Here correct answer is option A, that is it is true. Next is question 218. The time of flight t of a projectile on a horizontal plane is given by. Here friends, these are the options and correct answer is option A, that is t is equal to 2u sine alpha upon g. Okay, next is question 219. The distance between the point of projection and the point where the projectile strikes the ground is known as range. Options are correct or incorrect. Here correct answer is option A, that is it is correct. Next is the horizontal range of a projectile R is given by. Here friends, these are the options and here correct answer is option B, that is R is equal to mu square sine to alpha, R is equal to u square sine to alpha upon g. Next is question 221. The range of a projectile is maximum when the angle of projection is. Here friends, options are 30 degree, 45 degree, 60 degree, 90 degree. Here correct answer is option B, that is 45 degree. Next is the maximum height of a projectile on a horizontal plane is. Here friends, these are the options and correct answer is option A, that is u square sine square alpha upon 2g. Next is question 223. The time of flight t of a projectile on an upward inclined plane is. Here friends, these are the options and here u is equal to velocity of projection, alpha is angle of projection, beta is inclination of the plane with the horizontal. Here correct answer for this question is option B, that is t is equal to 2u sine into bracket alpha minus beta upon g cos beta. Next is question 224. The time of flight of a projectile on downward inclined plane depends upon. Here friends, these are the options, and here correct answer for this question is option C, that is both A and B, means angle of projection and angle of inclination of the plane. Next is question 225. The range of projectile R on an upward inclined plane is. Here friends, these are the options, and here correct answer for this question is option D, that is 2u square sine into bracket alpha minus beta into cos alpha upon g cos square beta. Next is question 226. The range of projectile will be maximum for a given velocity of projectile when the angle of projection alpha is. Here friends, these are the options, and here correct answer is option C, that is 45 degree plus beta upon 2. Next is the range of projectile on a downward inclined plane is dash the range on upward inclined plane for the same velocity of projection and angle of projection. Options are less than, more than, or equal to. Here correct answer is option B, that is more than. Okay, next is question 228. Match the correct answer for group B for the given statements in group A. So here friends, first statement is the Cartesian equation of trajectory is. Here friends, correct answer is option D, that is correct answer is option D, that is x tan alpha minus gx square upon 2u square cos square alpha. Next statement is the time of flight of a projectile on a horizontal plane is. Here friends, correct answer is option A. Okay, that is 2u sine alpha upon g. Next option is the horizontal range of projectile is. Here friends, option C is the correct answer, that is u square sine 2 alpha upon g. Next statement is maximum height of a projectile on a horizontal plane is. Here friends, option E is the correct answer, that is u square sine square alpha upon 2g. Next is the time of flight of a projectile on an upward inclined plane is. Here friends, option B is the correct answer, that is 2u sine into bracket alpha minus beta upon g cos beta. Next question is question number 229. The unit of angular velocity is. Here friends, these are the options, and here correct answer is B and C, that is the unit of angular velocity is radian per second as well as revolution per minute, that is RPM. Okay, B and C. Next is question 230. The angular velocity in radian per second of a body rotating at n revolution per minute is. Here friends, these are the options, and correct answer is option C, that is 2 pi n upon 60. Next is the unit of angular acceleration is. Here friends, these are the options, and here correct answer is option D, that is radian per second square. Next question is question number 232. Here friends, question is the linear velocity of a body rotating at omega radian per second along a circular path of radius r is given by. Here friends, these are the options, and here correct answer is option B, that is omega into r. Next is the linear acceleration A of a body rotating along a circular path of radius r with an angular acceleration of alpha radian per second square is. Here friends, these are the options, and here correct answer is option B, that is A is equal to alpha r. Next is which of the following are vector quantities? Options are angular displacement, angular velocity, angular acceleration, all of these. Here friends, correct answer is option D, that is all of these. Next is the motion of a particle round a fixed axis is translatory or rotary or circular or translatory as well as rotary. Here friends, correct answer is option C, that is it is circular. Next is question 236. In order to complete specific angular displacement by a vector, it must fix. Here friends, these are the options, and here correct answer is option D, that is all of these. Here friends, in order to complete specific angular displacement by a vector, it must fix direction of the axis of rotation and magnitude of angular displacement and sense of angular displacement. Next is question 236, sorry 237. When a particle moves along a circular path, its acceleration has two components. One is normal component and other is tangential component of acceleration. Here friends, options are true or false, and here correct answer is option A, that is it is true. Next is when a particle moves along a straight path, there will be centripetal acceleration as well as tangential acceleration, right or wrong? So here friends, correct answer is B, that is it is wrong. Now next is question number 239. 239. When a particle moves along a circular path with uniform velocity, there will be no tangential acceleration. Correct or incorrect? Here friends, option A is the correct answer, that is it is correct. Next is question 240. The maximum displacement of a body from its mean position is called amplitude. Is it right or wrong? Here friends, option A is the correct answer, that is it is right. Next is question 241. Frequency of vibration means the number of cycles per second. Here, yes or no, sir, then it is yes. Option it is true. Next is question 242. The time taken by a particle for one complete oscillation is known as periodic time. Agree or disagree? So here friends, question answer A is the correct answer, that is agree. Next is question 243. The periodic time of a particle with simple harmonic motion is dash proportional to the angular velocity, directly or inversely. Here friends, option B, that is inversely, is the correct answer for this question. Next is question 244. The amplitude is always dash radius of the circle equal to or less than or greater than. So here friends, option A is the correct answer. The amplitude is always equal to radius of the circle. Next is the periodic time t is given by. Here friends, these are the options where omega is equal to angular velocity of particle in radian per second. Here friends, correct answer for this question is option B, that is 2 pi upon omega. Next is question 246. A body is said to move or vibrate with simple harmonic motion if its acceleration is directed towards the mean position. Okay, is it true or false? So here friends, correct answer is option A, that is it is true. Next is question number 247. The velocity of a particle moving with simple harmonic motion is dash at the mean position, 0 or minimum or maximum. Here friends, correct answer for this question is option C, that is maximum. The velocity of particle moving with simple harmonic motion is maximum at the mean position. Next is question 248. The acceleration of a particle moving with simple harmonic motion is dash at the mean position. Here friends, options are 0, minimum or maximum. So here friends, correct answer is option A, that is 0. Next is the velocity of a particle v moving with simple harmonic motion at any instant is given by. Here friends, these are the options, and here r is equal to amplitude of motion and y is equal to displacement of the particle from mean position. So here friends, correct answer for this question is option B, that is omega into under root of r square minus y square. Next question is question 250. The acceleration of a particle moving with simple harmonic motion at any instant is given by, here friends, these are the options, and here correct answer for this question is option B, that is omega square into y. So friends, in this video we have seen part 5 of our theoretical questions and answer series on engineering mechanics. Thank you friends for watching this video. Like, share and comment for this video and subscribe my channel. Thank you.